Okay, so this is the part 3 of section 1 to my students' request of making shorter videos. I am making it the smaller videos. So this is the number 3 of 3 parts for section 3.1 for Savitch 10th edition. Section 1 we are looking at. Let me switch this. So 3.1 part 3, we're talking about short circuit evaluation. So one thing that, remember, this is computer science, C++ computer science. So if we can figure out something, then we don't want to do more work. So if there is a way to kind of shorten the effort, then we can raise the efficiency. So one of the questions that comes up is if we have and or, some expressions like this, of course, it can be much more than this, but let's focus on these things. And if we look at our and or truth table, how can I just look at the first one? So I just want to look at the first one and figure out, based on the first one, the whole thing. So we're looking at the and this is expression 1. How can I look at the first one without looking at the second one and figure out what the end result is going to be? Okay, so in this table, if this is true, it can be true or false. So based on the first one, if it's true, I cannot figure out the whole thing because it may or may not be true based on the second. But if the first one is false, the whole thing is going to be false, no matter what it is in the second part. So if the first one over here is false, the whole thing can be false. That's for the and. So for the and, but what about the or? How do we look at the or? So let's look at the or. This is what we're looking at. Again, I want to determine the whole thing based on the first one. So I'm looking at the first one for the or and the whole total things. Now, if I'm looking at the true for the first one, the end result is true. Doesn't matter what the second one is. So as far as I see true on the first one, I know the total is true. I don't have to look at the second one. But if it's false on the first one, I have to look at the second one to determine the result. So for or, as far as for the or, as far as the first one is true, the whole thing becomes true. Let's go over that one more time. So for us to know if the and result, I can look at the first one. So if this is false, this whole thing becomes false, no matter what it is on the second one. For or, if this is true, the whole thing becomes true, no matter what happens to the second one. So we got to practice on that. And that's called short circuit evaluation. So C++ does that. So it says if I have expression like that, and I can figure it out about the whole expression, I'm not going to go and check the second one if I already know. So in this case, I have x greater than what we call 0 and y greater than 1. Remember what we said about the and. If the first one is false, the whole thing is going to be false. If this is true, I have to check the second one. So in this case, if x greater than 0 is false, the whole thing is false. I don't need to check the second one. So X being a negative number, we are not evaluating if it's Y greater than 1 or not. If X is a negative number, we don't care if Y is greater than 1 or not, the whole thing is going to be false. Now, let's look at the OR. So I changed the X to 10. I'm checking to see if X greater than 10. Remember, for the OR, all I need is the first one to be true. So for the OR, if X is greater than 10, doesn't matter what the Y is, the whole thing is going to be true. As far as X is 10 or above, because I have an equal sign, if it was just X greater than 10, the 10 would not be acceptable. But because we have greater than equal 10, then as far as X is 10 and above, it doesn't matter what the Y is, the whole thing becomes true. So how does C++ or languages like this use this in the advantage? So we might have some consideration of, okay, if we have a division by 0, we can potentially have a runtime error. Remember, runtime error, we might not catch it, we might not check it, and then later on it's going to come and bite us. So we have to be careful with these things. So one of the common problem in the runtime error is if I have a division by 0. So in this case, if number of kids are not 2, then we're going to have a problem. So what's going to happen? Let's say that the number of kids is 0. I don't have any kids. And if we run this, then we're going to have division by 0. So what do? We put this one in here, and we're going to do the AND in. So if the kid is 0, this becomes false. And remember, for the AND, as far as the first one is false, it's not going to even check the second part. So the only time it's going to check the second part if the kid is not 0. So this has to be true before it does the second part. So that's what the short circuit means, that based on the first one, we might not even do the second one. So for the AND, if the first one is false, we are not going to do the second one. For OR, if this first part is true, we are not going to do the second part. So we can use it in our advantage, or if we want to think about these things a little bit. That way we don't have the runtime error. Okay, so I'm putting this activity up for be sure that you're going to go over it. Remember about the NOT, so we can practice on this, and we can talk about it in the class when we meet again.